Have you ever wondered how they create those 3D images inside crystals? Yeah, me too. Unfortunately, there wasn't a single good video on YouTube explaining it, so I decided to make one. Welcome to Maker's Muse. How's it going, guys? My name is Angus and welcome back to Maker's Muse. So a bit of a backstory. I remember when Westfield Bondi Junction opened its doors back in 2003 when I was a kid, and up on the 5th floor was a futuristic looking store that offered to turn your photos into 3D images inside hunks of crystal. I think the store even offered 3D scanning as well, which way back then was a not cheap suite of tools. Suffice to say, they quickly went broke and disappeared, but the concept of a customized three-dimensional image inside a cube of glass intrigued me ever since. Fast forward to 2016 and I had the pleasure of visiting Shining 3D in Hangzhou, China, and as a gift they captured a 3D image of my face and put it into a crystal using a machine they sell. So how the heck did they do it? Is it some kind of 3D lattice they pour glass over? Is it created layer by layer? Are lasers involved? I had no clue, but I wanted to find out. Well, the technology is known as subsurface laser engraving, or vitrography, or a bubblegram. Personally, I think vitrography is incorrectly used as it references a manual process of layering glass, and bubblegram just sounds stupid, so subsurface laser engraving it is. But before you can understand SSLE, you need to understand how laser engraving works with glass. Having worked in the laser engraving industry in the past, laser engraving on glass is actually really effective despite what you might think. You see, when the laser is focused onto the surface of the glass, the intense heat gradient creates microfractures. Combine this with rastering and engraving, and you can actually create really legible frosted letters and logos on the surface of glass using a laser. Any of you guys out there who have a low-cost CO2 laser system really should give it a shot. It works really well. But how do they get the image inside the glass, not just on the surface? Well, you see, any laser engraving system has a lens to focus the beam to a tight, concentrated point. Because of the optically transparent nature of the glass used in these machines, this focus point can in fact be within the glass itself. It's almost identical to traditional surface laser engraving, just with a height or Z component. The machine simply has to aim it at the right place within the crystal and fire. Bam! Instant internal fracture, which forms the appearance of a small bubble. In fact, the laser point size of modern systems is only 40 to 80 micrometers in size, and they can pump out over 4,000 dots per second. And because the laser is only focused at a very specific point, it doesn't cause any damage to the material as it passes through. But it's not all so simple. Anyone who's looked at a straw from the edge of a glass filled with water will know that the refractive index of a material greatly affects the speed at which light travels through it. And this is bad if you're trying to precisely focus a laser through a material at a specific point. So the crystal used is specially selected, although you can use clear plastics, it's just not as effective, doesn't work as well. The material also needs to be of very high optical clarity, something similar to what would be used in a lens, for example, such as SHOT BK7 or Chinese K9 borosilicate glass. Crystal is usually specified. Sadly, one trade-off is the final product is pretty fragile. Don't drop your cube. But what about the image? Well, the final effect with a grid of tiny dots is selected for several reasons. Firstly, you can't just blast solid etches inside the glass because you'll damage the piece, and you won't be able to see through the solid image anyway, it'd just be a mess. Secondly, it turns out the laser diodes used in these machines are pretty expensive, in some cases 1/3 of the overall machine cost, and have a very specific lifespan. Pulsing the laser for tiny dots is far more economical than just blasting a solid vector, and less dots is more economical still. So if your custom glass cube has really sparse dots, they were probably cheaping out on you. The images used in these systems are either JPEGs, which are 3Dified using special software, or a mesh file similar to what you might be used to in 3D printing. However, unlike 3D printing, you don't need to have a manifold perfect watertight mesh. In fact, you can use pretty much any mesh file you throw at it, which makes the post-processing aspect of running these machines actually quite low. You just take the mesh, crop it, size it, and position it, then let the software turn it into dots and send it into your glass cube. There's actually an awful lot of science that goes into the behind-the-scenes creation of these shapes. For example, if the dots are too close together, they can form what's known as a clash, where there's an internal crack between the two dots. they're too close, so the 3D dots are specifically layered to avoid a chance of this happening. But realistically, it's all actually handled in the software and it's far too complicated to go into in this video. So at this point, some of you might be wondering, wow Angus, these Bubblegram, surface laser engraving machines sound pretty cool. How much do they run for? Well, they started around 20,000 USD. And go up from there. So it's mostly due to the high cost of the laser diode and the optics used, which is probably why you don't see too many of these laser systems around. Nonetheless, the technology is quite fascinating, and I'm sure we'll be seeing ugly 3D selfies and glass cubes containing the 3D wisps of popular tourist destinations for years to come. But now you can tell your mates exactly how they were made. Now I'd like to take a moment to thank the sponsor for this video here on Maker's Muse. You guys. Thanks to you guys